The architecture, the diagram will look like this. So suppose that we have client application. It can be anything, desktop or user using the mobile. It will send a request. It will go to the one centralized software tool. So this is nothing but the API gateway, and this will forward this request to other services. Service 1A, service B. Mostly it is used in microservice architecture. C, D, and it will connect to the database or all those kind of things. Okay, so it is nothing but a centralized software tool that acts as a single entry point and management layer between client application like mobile apps or website and backend microservices. It it routes the request, it acts as a load balancer, it will cache the response coming from the services, it will apply the rate limiting, it will handle the traffic, handle the logging, simplify complex service architecture into single API endpoint. So not client have to send a request to service A, service B, service C, service D, but API gateway will handle all these things. So we have here client, it can be anything, web, mobile, external app. So first it will send one URL, it will go to the DNS resolution, domain name service resolution. Then it will go to the load balancer. It is optional, we can have load balancer or we cannot have the load balancer. And now we have the API gateway entry point. So here what it will do, it will do the authentication check, rate limiting or throttle, logging matrices, all those kind of things, and then it will send this request like header, body, schema. Request validation happens, request transformation happens, like it can modify the headers, payload, anything, routing logic, all this is present in the API gateway. This is all we talking about, this is happening in API gateway. This is nothing but a software tool. So actually we have coded all these things, like for the authentication we might be using JWT, rate limiting we are using some annotations from the Spring Boot, filters, logging and all those kind of things. For logging we may be using some other library. All this is in the API gateway tool, and this is initially before API gateway all this logic used to reside at the service layer, making it bulky. So all this is happening, and then routing logic, like if I have service A, service B, but URL is different, so we have to route this request coming from client to service A, service B. We have to route it, like routing is nothing but we have to find out the server's IP address and we will have to forward this request to there, and all this is happening into the API gateway in this section only. And now it will finally go to the service A, service B, service C after resolving the URL, after routing happens. So now in the service the business logic execution will happen, then we will get the response. We may aggregate the response, we may not, and this is the microservices. These are the microservices. Now again when it returns this response, it will transform the response. Now we are getting the response from service to this API gateway tool. It will transform it, like process it before returning it back to the client, or sometimes it may cache it, like user is continuously requesting for the same data, so it may cache it, like save it temporary in its memory, and when user asks for the same data hitting the same URL, it is going to return this response instead of going to the services, actually making the HTTP call to the services to the server. So this saves the time and resources. Also it will handle the logging, monitoring and client response as well. So it is nothing but all the steps, like a request originates from a front end app, third party system, another backend service or mobile, anything, then it will go to the DNS or load balancer. So suppose that I am ordering something online from my phone, I will go to the app and I will send add something to the cart, and it will go add something to the cart, then will go to the payment services and all those kind of things. So this is our all the microservice, like payment service, adding to the cart, handling the offers, all those kind of things, handling the banking transaction. These are kind of microservices hiding behind one application, one shopping application like Flipkart, Amazon, Myntra, anything. So now we are now the request will go to the DNS, like domain name server. It resolves the API domain. Now load balancer distributes incoming traffic across multiple gateway instances for scalability. So that is the work of the load balancer, which is optional. Suppose that we have the heavy traffic to our website or to our server, we can use the load balancer. It will balance the load, like it will distribute all the requests. Incoming traffic is nothing but the incoming request. Then suppose that we have multiple gateways instances, that it will suppose that 20,000 requests to the first gateway, 30,000 to second, like this, instead of sending all the 50,000 to one endpoint. So API gateway entry point, this is the central control layer where all requests first arrive. Then authentication and authorization is happening. So it validates the request using the JWT, OAuth or API keys and reject unauthorized request early. So instead of this logic happening on the service, inside the service on the server, that will make it bulky. All this happening before reaching to the actual server inside the API gateway. So rate limiting also handled by this API gateway. So what happens, what is rate limiting? So instead of 10,000 we can define that this endpoint, suppose that cart user /cart /abc, this endpoint will only handle 5,000 requests in 10 seconds, 10 seconds, 20 seconds. So that we can define, instead of bombarding this endpoint with lakhs of requests and making it slow. So this is nothing but rate limiting, like we are limiting the number of the requests. It see here they have said that ensure fair usage, like 100 requests per minute per client. Logging and metric collection, track request count, latency, error. It will make our service better, and we will know as a developer where we have to work, where the latency is occurring, and all this data will be present inside the gateway, not on the server, not on the separate. We don't have to go to the separate service like service A, service B, service C. Instead we will check all the data at one point, that is at the API gateway. We know that we have the CloudWatch. CloudWatch is the service that is provided by AWS. It will have all the data, all the logs that we have inside our application. There is certain syntax that we have to follow, that will go to the CloudWatch, and we can create visualization. We can check, we can filter certain words, certain correlations ID to uniquely identify that endpoint, that this is coming from this endpoint. This will make just everything easy with CloudWatch. So it is nothing but the logging or metric collection tool. Request, so this is also happening in the API gateway. So request validation, ensure request structure is correct, validate headers, query params and payload schema. Again all this is happening in the API gateway and not at the service. It can transform the request before it is sending to the service. It can transform the request, add, remove the header, convert format XML to JSON, normalize the payload, like remove the extra data, all those kind of things. We can put this logic inside the API gateway as per our service need. Routing logic decide which backend service handles the request. So suppose that I am cart /user abc/cart. So this is something, this endpoint will go to the service which is handling the cart logic, like user have added what things have user added, what things user is removing from the cart or adding to the wish list, all those kind of things. All this logic will be inside of this /cart endpoint. So it now this is the routing, like which backend service handles the request, the endpoint. This is also happening now inside the API gateway, like path based, method based, version based, all these things that is handled inside the API gateway. Gateway forward, now gateway forward the request, routing is done. Now gateway forward request to appropriate service, services process business logic independently. Now this is sending, API gateway sends this request to the service A, B or C depending on the what routing logic decide. Then this ABC again. So now this is the user, this is API gateway. Now this is service A, B, C. So it is sending the request. It will go to the A, B, C. Suppose that B, we didn't get any request to the B. It will aggregate the response. So suppose that we need to aggregate the response from service A and C. It will happen in the, we can put that logic inside the API gateway. It can transform the response, like filter some data, filter out some data, only pass the necessary data, maybe cache. It will caching layer, store frequently requested response, reduce backend load and improve latency. Suppose that I am user wants something, ABC data, all the things authentication authorization happen, it is going to this service B, and B is returning some response. API